Hi, Mr. Champion again, here to talk about lattice multiplication. We've been talking about it in class for several weeks. We've been doing it during math races for a couple of months, actually. And it was just this week that I really got into the heart of what lattice multiplication means and why it works the way it does. It's very connected to partial products, and I'm going to show you that at the end. Let's get started with lattice multiplication. So you can see I have the same problem that I had in the previous video, 473 times 94. Now, in lattice multiplication, before you can set up your grid or your lattice, what you need to know is how many rows and how many columns you're going to have. The bigger of the two factors is going to tell you how many columns you have. So for example, the biggest factor of these two is 473. It has 3 digits, therefore you are going to have 3 columns. The smaller of the two factors is 94. It has 2 digits, so therefore you are going to have 2 rows. So let me show you what that's going to look like. So you end up with a grid that looks like this. 2 rows. What you want to do next, and my kids have a lot of fun talking about the corners, is you connect the corners. And what you end up with is your final, well, almost your final lattice. And it looks something like this. Sorry, let me back. Okay? And what's really cool about this is what you'll see once we finish is that each little space represents a place value. And it'll make more sense once we get started. So once you've gotten your grid or your lattice all ready to go, you then place the factors above the spots on the lattice. So as you can see, our bigger factor went on top, 473, 473, and then our smaller factor, 94, went on the side, 9 and 4. Then the rest of it is pretty easy. You just do the multiplying. You take, very similar to partial products, you multiply the 10s times all the other place values and the 1s times all the other place values. But what's really neat is the lattice or grid helps to organize your products. So let me show you what we got. So as you can see, we did 9 times 3. Sorry, let me move over a little bit. We did 9 times 3, and we got 27. Right here, 27. The 2 goes above the 7. That's how you separate the 10s and the 1s. In each of your multiplication problems, you're going to be using basic facts, and you'll place the 10s in the top part of the lattice and the 1s in the bottom. So then we did 9 times 7 is 63. 9 times 4 is 36. Then I go down to the next row, and I have 4. I do 4 times 3, which is 12. 4 times 7, which is 28. And 4 times 4, which is 16. So I've organized, I have it all set up in my grid. Now I'm just ready to add. And what you're going to do is you're going to add your diagonals all the way through here. So your 2, and you're going to do 7 plus 1 plus 8, 2 plus 3 plus 2 plus 6, 2 plus 2 plus 1, or excuse me, 2 plus 6 plus 1, or 6 plus 6 plus 1, and then 3. It'll make more sense on the next card. If I can find the next card. So once you've done all that, what you end up with, you haven't done yet. I'm so sorry. Let's keep going. Just bear with me. So we add, this technically is now the 1's place. Okay? So we do 2 plus nothing, which is 2. So let me just write that down for you. And I'm actually going to do the rest of the addition as well, and then I'll come back and talk about it. So I'm doing the 7 plus 1 plus 8. I carry the 1, 3, 6, 8, 14. Carry the 1, 7, 13, 14. Carry the 1. Okay, so let's come back to this. Sorry about that. So, what you end up with is, 2 here. Then you had your addition, 7 plus 8 plus 1 was 16. Then you had carried the 1. 1 plus 2 is 3. Plus 3 is 6. And we're in this column now. This diagonal. Plus 2 is 8. Plus 6 is 4. Then you carried the 1. 1 plus 6 is 7. Plus 6 is 13. Plus 1 is 4. 14. You carry the 1. 1 plus 3 is 4. So your answer is 44,462. Now, what's really neat about the connection between partial products and lattice is that you basically added up the same numbers. And I apologize. So, if you look at our partial products from a previous video, and, let's see. You see that we had, in the ones column, we had a 2. Well, in the ones column, we had a 2 here. In the tens column, we added 1, 8, and 7. 7, 1, and 8. The same. And remember, according to the commutative property of addition, order doesn't matter. So it's the same addends. So it'll give us the same sum. Then in the hundreds place, we carried the 1 obviously, but we have 2, 6, 2, 3. And in the hundreds place there we have 2, 3, 2, 6. Same addends. And it's the same way for the thousands and for the 10,000s. So the connection between partial products and lattice should be somewhat obvious. What mathematicians did several centuries ago is they realized that people were having difficulty keeping the place values organized. So they came up with the nifty little grid system or lattice system to help organize the numbers. So remember, the tips to remember about the lattice is the biggest factor tells you how many columns you're going to have. We had 3 columns in this problem. The smaller factor tells you how many rows. We had 2 rows in this. Remember to connect your diagonal, connect your corners. And then you just multiply and add. And it turns out really well. It's a pretty cool method, and it actually, from what I've seen in class, has been a very consistent method for most of the students. So, hopefully, after watching these 2 videos, you have a better idea of how partial products and lattice multiplication work. And thank you for your time, and good luck.